Thank you for joining us. Appreciate everybody coming out on a Sunday morning. And thank you to Charlie with Altered Confusion here for covering and recording. So we were talking about why video games take so darn long to make, and maybe more importantly, what you can do about it. The talk is really is centered around video game development. That's our experience, but I think a lot of what we say will apply to any kind of creative endeavor, whether you're making film, whether you are making music, making visual art. So hope everybody can find something that's helpful. With that, Sarah, get us started, please.
Sure. So this started in part in, I think it was 2018 when we came to MoCon, and we came to a lot of panels like this, and we were looking at different game devs who, a lot of them had real similar stories. You know, we quit our jobs 5 years ago, we made this lovely game, please buy it, we're broke. And for some reason we thought that would be a great idea, we should do that too. So, but you know, at that time I heard all these stories and I was like, does it really take 5 years to make a video game? Like, that seems kind of excessive. I think anyone who spends 5 years making a video game is maybe a moron, doesn't really know what they're doing. 6 years later, I stand by that statement. I really had no idea what I was doing, and we've learned a whole lot of lessons over that time of why it really takes so long. And because I kind of had the framing of that question up front, every time something would happen, it kind of tickled the back of my brain, like, oh, this is another reason why it takes so long. And so, also, just to add to the irony, we were fully planning to have the game launched, our first big game launched and ready to go, and of course it got delayed. So in August, try again. We should really be launched for real this time. For real. For really real. And just a little bit of background, this game isn't really about the game that we've made, but because that's our context, it'll give you a little bit of an idea. So the very first game that we made was called Island Hopper. I put it on the Google Play Store. It was a real simple strategy game where you control some islands, you send your planes to go attack the other islands. It wasn't very complicated, but I just wanted to have a project that had, you know, start to finish, conceptualized, put together, published. We put it up for free. I tried for like 2 minutes to put ads on it and made the experience awful. I was like, never mind, I'm not doing that. Just put it up there, it's fine. And then after that, we're like, okay, let's do like a medium-sized game. Let's do something a step up from that. That was maybe like 6 months, kind of nights and weekends, not full-time. We're like, let's do this for real now. We'll do this full-time and try for something that's, you know, 18 months size. And like I said, it's been 6 years. So
Island Hopper was what, a couple weeks, I think, for the whole thing?
It's hard to say because it would be so much faster now.
It wasn't full time either.
Right. But it was the very first thing, so just lots of lessons of writing. So I think it was longer than that, but like real time actually making it, yeah, it was pretty quick and pretty simple. So this is the game that we are releasing now. We have a booth downstairs in 109 if you want to come by and play it. Check out the demo. The demo's on Steam right now, so you guys can play that free and live. We have 4 different game modes going on in this game, and like I said, it's not really the point, but just to give you some context so when we refer to the game you know something about what's going on. The top mode is like a point-and-click style, and you're not interacting with the main character directly. That's Elon in his little suit running around there. And you are this omniscient AI who's running around trying to manipulate different cloud-connected devices around him to keep him safe, get him out of trouble, get him where he's trying to go, all those kinds of things. Later in the game, you get to upload your consciousness into a husk, which is the second little guy, and so you can actually interact with the world, run around, move and grab things.
The Android shelf, the AI, the Elon Husk.
So there are also some levels where attack drones are sent after Elon, so you take control of a space laser and start blasting them out of the sky. So just like I said, a real kind of quick overview of...
We have a 4th mode as well. We're going to get into more detail because we want to use that as a specific example as part of the later talk.
Just broadly, I mean, there are an infinite number of reasons why video games take so long, but we've broken out 3 different sections that encompass some of the main points that we really learned from. So design, infrastructure, communication, and then hopefully we'll have a little bit of time at the end for questions if you have those. The first reason that really struck me is why video games take so long to make is because sometimes the ether is stingy. And by that I mean, when you sit down to design something or do something creative, you very frequently sit down, you're ready to go. It's like reaching out and grabbing into the void and trying to find some idea or concept or something that you can use and put together and make it into the thing that you're making. If you've ever, encountered writer's block, it's the same kind of concept where like you sit down, you're ready to do the thing, and there's just nothing there today. And some days it would be the opposite. You'd sit down and you've got like more ideas than you can keep up with, and you're losing them because you can't write them down fast enough. And some days you show up and there's just nothing. And getting some good sleep, eating right, the exercise, all those things help. But sometimes I would have days where everything is set perfect. I'm going to really nail it today, and it's just there's nothing there. Or even sometimes you'll have lots of ideas, but none of them are really applicable to what you're doing. Maybe you can. That's a good idea for somebody's game, but not for this game, or it doesn't make sense, or doesn't fit within the constraints of the game as you presented it. So, and there's also a difference between modifying what exists and making something totally new. And when we first started out, I found it real easy, like if my partner would make something, and I would see what it is and be, oh, we can tweak this, we can make this better. And so it's like, I feel really good because I made it better, but the hard part was coming up with the thing in the first place. And the first time, talk about that, man, when I tried to do that, it was a disaster. So, but one of the other really big reasons from a design perspective why video games take so long to make is sometimes your crystal ball is garbage. When you sit down to plan something and you think, what's it going to take to fulfill this creative vision that I have, you might think, oh, that seems pretty straightforward, it's going to take a week. Well, if your crystal ball is good, maybe that's a good prediction. If your crystal ball is bad, maybe it's 3 months and you didn't realize that, and maybe it's because you didn't understand the complexities of what you're doing, and as you start to actually implement it, you discover some of those problems and you realize, oh, this is way more complicated than I thought. And by far the biggest issue with our game was not scope creep so much. We had a couple of places where we decided, okay, we really need to extend the scope to make this game better, but by and large it was, this is what we want to do, and we're fulfilling that, but we had no idea how complicated or difficult that thing was going to be to actually make.
I think you called it scope development yesterday, which
Yes.
is extremely appropriate.
So there's this classic XKCD about this guy has this idea for an app. He goes to his programmer friend and he's like, make this a little better or something. But he asked, I want to make this app. You're going to take a photo. And first you're going to check and see, are they in a national park? The programmer's like, okay, you can, GPS, it's not that hard. And then, let's check and see whether the picture's of a bird. And the programmer's like, well, I'm going to need a research team in 5 years. Like, that's a completely different problem. And with the advent of AI, that's maybe not quite such a big leap anymore, but in general, when you're programming and developing, it can be really hard to explain the difference between easy and virtually impossible. And when your crystal ball is not very well developed, you sometimes look at it and think, oh, this will be really easy. And maybe it's virtually impossible.
And a lot of times that has less to do even with your programming ability and more to do with your game design and development experience as well.
And that was the thing that would happen frequently is we would sit down and have a design session together and come up with, okay, this is how we're going to do it. It's going to be great. And I would go to implement it, and sometimes it's like 5 minutes, and I would realize this is logically impossible. Like, once you start to actually do it, there are logical reasons why this is not even possible to make. And I'd come back and be like, yeah, we can't do that. And you'd be like, why? We talked about this. Like, well, it doesn't work. And when your crystal ball gets a little more developed, you see those things coming a little better, you can predict those a little better, and so it gets a lot easier. But when you just don't have a good sense of predictive ability and your crystal ball is garbage, it's a struggle.
Next.
So the first time this really, both of these came together and hit me in the face, we designed several levels, but I hadn't really done much of the design work. I started to get the itch of like, I want to design my own level, I'm going to sit down from scratch, I'm going to make something, right? And so I did, and it was like pulling teeth for every little fragment that I was able to pull out of the ether. It was just like all these little tiny ideas, and it didn't quite make sense, but I was going to smush them together and make something out of it. And so, as you've seen, we have this 2D game, and I was like, it'd be really cool is if we had a third dimension, and you could like have a crane move things around and up and down, and I completely did not understand the constraints we had placed around the game. It's a 2D game, and I tried to, we'll just make a third dimension, it'll be great. And like you saw in the very first part of the game is where you don't control the character directly, you're manipulating things around it. And so from the design perspective, I was thinking, oh, this will fix all of our design problems because you can interact directly now. You have this crane that moves around, you can pick things up, move it around. And it like completely missed the entire point of that style of the gameplay. It was trying to subvert it. And there are absolutely ways that you can do that well, but I didn't understand what I was doing, so I missed the point there. And similarly, even with like 2D and 3D, other people have made games where they kind of solve that give you that impression of 3D in a 2D environment, and they can do that well. But that's a technical challenge that you have to be aware of and understand and set up to solve, not just try to throw it in as an afterthought. And one of the places, that became obvious was because you only had 2 dimensions to work with, when you pick something up with a crane, how high do you know is off the ground? And like the first solution is, well, you put a shadow under it. So there's a shadow on the ground, and when you pick it up, the shadow stays still, and the thing moves up and down. Which is great, except I put a whole bunch of tables in the room. So now what happens when you move over a table? Does the shadow jump up onto the table? Like, physically that makes sense, but how do you do that in code? Is it a special case now for every table you have to work out? I mean, that gets complicated. Furthermore, like, shadows don't sit halfway on the table. You have to like split the shadow in half, put part of it on the ground, part of it on the table. It becomes all of these technical questions about how you implement it to make it work. And maybe you can make the shadow kind of fuzzy and you can kind of fudge it around the edges and make it work. But even then, after all that, if the crane moves behind the table, now the shadow is completely obscured by the table. So you've lost the ability to gauge how high things are off the ground, and it becomes this technical nightmare. It's again not to say that there weren't solutions, but I pulled these ideas out of the ether that weren't quite right for the game, and the crystal ball didn't expect all of these technical problems to solve before I could even get started with the design of the game.
I had forgotten about the shadow problem, because I've not been allowed to talk about this level for the last 3 years.
We literally call it the level which shall not be named. It has been completely stripped from the game. It is gone. There are maybe a few sprites that got reused in other places, but this went catastrophically wrong. And
it burned a month, I think, at least on its own.
Right. He spent a bunch of time making some of the art assets. I had this whole controller for the crane and how it was going to move around and all of this. And again, even after all that, it wasn't fun. Like, you just move things around the room until it works. It didn't make a lot of sense. It wasn't very interesting. It wasn't much of a puzzle. It's supposed to be a puzzle game. It was not just, it was terrible. And we ended up having to rip it out of the game. And so sometimes, because especially when your crystal ball is bad or you're pulling poor ideas and trying to force them to work, you end up wasting a bunch of time and you gotta start over from scratch. One of the other big examples we ran into was...
And no, you're not supposed to be able to read that.
Yeah, so this is just kind of, it's not even actually the exact image that we had, but we would have design sessions where things like this would come out, and we'd write down these huge lists of all these mechanics we want to do, or ideas and how they would interact, and to-do lists, and we'd have these huge lists. And one day we had at least 20 items on this list, and somewhere around like 14, we'd put pathing with 3 question marks, because we were like, I don't know, do we need that? It seems maybe important. We have this game where the character needs to move around by himself, and you want to interact with him somehow. It seems really natural when you're designing it. You realize you want the player to, like, I don't know, stick things in his way to change his path, or move his path, or adjust his path. And we just programmed him to blindly go from point A to point B at this particular point in time, and then go to the next one.
We had waypoints, that's enough, right?
But yeah, he really didn't care if there was a truck, a box, a wall in the way. He would just blindly run through, and if his glider got caught on things, whatever, it was just abysmal. And we kind of like worked around it from a design perspective for a long time and realized, no, it's really actually fundamentally important that he be able to choose his own path that makes sense through this environment. And it was just embarrassingly late because our crystal ball was so bad that we realized we needed to solve that problem. And that's several months of figuring that out, working out the bugs, working out the kinks, creating a system that makes sense for you. And so sometimes there's just this black hole lurking in your design that you didn't know was there. When you run into it, well, add 3 months to the project.
That's enough problems for now, right?
Yeah.
We got some solutions, maybe? So one of the things we discovered that really helps a lot is to constrain what you're working on at any given time. So this might be at a high level, might be constraining your genre, your interface, your controls, or the platform you work with, or a lot of times it's a lot lower level, like a specific kind of mechanic inside your game. And the temptation, I think, early on, if you have a lot of good ideas, is to use all your good ideas because they're good ideas, right? And the reality is that a whole bunch of good ideas together don't necessarily make something good because they may not fit well. And so the earlier you can constrain what you're working with, the faster you can start iterating on a single idea and see, does it really fit in with my game? Or how can I alter it? Or maybe it doesn't really work the way I thought it would. Or maybe it does work, but it's not fun. And I can alter it to make it more fun in some way. Constraining what you're working with helps a lot. Even if you have a bad constraint, even if you say, we can back this out and choose a different path, you're still faster putting some restrictions on yourself, moving forward, and then backing out and trying something else than just letting the ether swallow you whole. Another thing we found pretty early, not early enough, I think, for us, was getting some experience, and I mean this in a very specific way, is really helpful. I don't mean game design experience, because if you're trying to make a game in the first place, you're probably pretty good with game design already. You're interested enough, you've played a lot of games, you have a good idea of mechanics, you have opinions on things, and that's important. You know what's fun and what's not. But there's a whole other kind of experience that's not the game design, and that's the actual implementation of things. So experience with your engine, with workflow, with programming, with making animations, all of those things. And that experience, I think, is pretty easy to kind of, you can power level yourself pretty easily by simply pick a game that's already made, something that's already fully designed, fully implemented somewhere, so you know how it feels, you can touch it and play with it, and just remake a little piece of something someone else has already made. If you are several years in, if you have several projects under your belt, this may not help you. It might if you're moving into a new genre. But especially if you're new, just remake a little piece of something. Pick a single room, a single level, a single enemy encounter, whatever it is, and remake it yourself. And what you'll find in doing that, using your own engine, your own code, and even trying to remake the art assets yourself, you'll find where the sticking points are going to be, and a lot of times they're not where you thought they were. And the reason that's important is because you can either alter how you're looking at the problem, or you can start making tools to help yourself with it. You can automate some things. You can do all kinds of programming to augment your engine, or maybe beat your engine submission, depending on what you're using, to help yourself, which is really the next point on here. That's infrastructure. Be liberal, I think, with the amount of infrastructure you're willing to make for yourself. If you think that something may take 5 minutes to do and you can do it 6 times, or you can automate it for 2 hours, I'd still go for the 2 hours, because it might be 2 hours versus 30 minutes now, but the fact is you're going to change stuff and you're going to iterate so many times that over the course of time, over the course of the game, it'll pay for itself. And sorry, go ahead.
When you know that tool is there and it makes it easy to change things, you're mentally freed up to have the liberty to make those kinds of changes.
That's true.
It's really easy to get stuck like, I don't want to spend 30 minutes doing this one simple thing, but if you know there's a tool for it and you can just do it, it makes it so much easier to have the creative freedom that you want. Yeah, it doesn't only save you time, it gives you more creativity.
One other solution that I think helps a lot is to have some kind of existing paradigm for your first or second game. Certainly not saying copy what other people have done. What I mentioned in experience is just not something you'll use for your game, just something to get your own experience. But once you're actually trying to make your thing, pick something that's similar enough that you can use as a reference. And the reason that's important is anytime you think you have an idea that you may or may not want to implement in your game, think how it would fit in something similar and see how that works. Maybe don't try to use a perspective that's not native to your engine and combine a bunch of genres and do some unique puzzle design and include an entire story all in this your first game. That may not be the best.
It might take 6 years.
It might take 6 years. But you might not finish it all. And I've alluded to it a few times, but really iterate as much as you can. I think expect to throw out 2 or 3 times more than what you keep in the end. And I think considering your game is more of a sculpture where what you remove is more important than what you add is probably an appropriate way to look at it. Iterating is very, very important. So we have a couple examples now for design. And the first one I want to talk about art choices specifically. We've been talking a lot about game design things, and like I said, this art is obviously very important in a video game, but it can work in just an art endeavor, purely art endeavor as well. So what's on here is the sprite equivalent of the. Oh, I need the next one? Thanks. Technical assistance here. This is the sprite equivalent of that real edgelord poem that you wrote in like middle school when you were 12 years old, and then you read it 10 years later and you think, it's okay, I'll just move to Antarctica, no problem. This was my first attempt at the Elon Musk. This was without any kind of constraints. I just thought, I don't know what I'm doing, I'll pick some colors and I'll put some pixels together, and I'm sure it'll be fine. I didn't have any good sense of what we were going to be using for the animator. We thought our engine has a built-in animator, it's fine, we don't need to worry about that. I didn't have a good sense of how large exactly a sprite should be, or didn't have any kind of style guide. And so, to improve on this, ended up putting some constraints on this. And this was a very gradual process that happened over the course of the game. If I had known I should have constrained things better up front, I could have definitely iterated a lot quicker, as you'll see in a minute. One of the first things we did was use a palette. We decided this is maybe not the most interesting thing to look at. A lot of times we wanted more saturated colors, so it'd be easier to see and just kind of nicer to look at. So we made a specific palette and used that. Maybe 40 or so colors that we picked that most of the game is comprised of. Did some work standardizing sprite sheets, really started to develop a style guide, which is a whole talk on its own. If you are planning to do art and you're not familiar with the style guide, it would really help to look that up. That's not meant to be homework, that's really meant to save time. I wish I would have known about that concept before I started. A couple of the things we did on the infrastructure side is we created our own custom animator as well, because a lot of engines don't do great with pixel art. And we also created a little preview window inside our editor so we could see more real time what the animations look like. So that helped us, there we go, iterate to something that looked a lot better. So when you can iterate quickly, you get the experience of actually doing the thing instead of fighting your engine, fighting your infrastructure much quicker. So here are a couple examples when I was talking about the palette. This is just a layer I kept on a Photoshop template that I use for every new sprite sheet in the top left. On the bottom left, the color choice, I included a little arc, and this was an arc that we found some through trial and error, some through some art guides and things like this, where anytime you want a new color on your palette, pick something along the arc. Don't do a diagonal line, don't do it across the top or across the right side. You'll end up with something that's either low saturation or low contrast, and it's just kind of hard to read and parse as the player. And then on the right side here, you'll see our preview. So instead of having to play the game each time, we'd have to enter play mode, which may take 30 or 45 seconds, and then we may need to get to the part of the room where the animation is actually happening. So for each iteration, instead of a minute, 2 minutes, we can just see immediately within a second or two how the animation is going to look. So that way we can see Craig tipping his fedora to the nearest Malay in real time, and that's important. Second example is the force play mode you're talking about. This is our driving level, and we knew we needed Elon to drive his Edison at some point, but we did not know what that looked like or how we were going to design it. And any kind of classic driving interface, sorry, there's a fly in front of my face. Any kind of classic driving interface you see in driving games was really not going to work with what we had. We had this 3/4 ISO perspective for the rest of the game, and we're not quite sure how driving should look and what it should be. How are you going to control the wheels? How are you going to show whether it's objects on the road that are in your way, obstacles or dangers? And so what we ended up doing is kind of pulling from a few different games we had played. We knew that when we do use Unity for this, Unity handles 3D physics well. For the 3/4 ISO stuff, we were really fighting the engine, so we thought, all right, let's try to embrace the engine for once. Let's try to give it a hug. And we also we played through some other games. We had recently played Franbo, and which is a point-and-click puzzle. I think I still call it a puzzle adventure game. And as part of that, in between each chapter, they have these little interludes. They're mini games. They're maybe 30 seconds long or so, but it kind of left you wanting to play the little mini games some more. Maybe not for the entire game, but you wanted more than 30 seconds. You just got to play once and you were done. And I realized that change of pace briefly from the game was a nice break, and we liked it, and I wanted something that felt the same way. And we also really liked the concept of like the needy modules from the game Keep Talking and Nobody Explodes, where there's some core gameplay that's happening, but at the same time, there's other things that you just need to keep up with. It's just a lot of multitasking and doing some puzzles that on their own would be simple, but when you have a lot going on, it's complex. So we put this together and decided that for driving, you're going to do less driving the actual car and controlling the car directly, and we want to lean into this multitasking. We'll have a completely different style, we'll have a completely different UI to it. And so what we ended up with is something where you're driving down the road and you have all kinds of, what do you call them? Dangers, things come up. Elon tries to escape because he has no attention span whatsoever. He starts wiggling his butt out the window. Or maybe he gets too hot or cold and you need to turn on the AC or the heat. Maybe you're going through a tunnel and you need you turn on your headlights. And each of these, any kind of command you give to the car, you have to solve one puzzle to make it happen. And so that's what we ended up with, and it ended up being pretty fun. I think we've probably gotten, out of all the different modes, we've probably gotten the best feedback on this one overall. So this was just an example of, like I said, using some other existing paradigms and really restricting what we were doing to get a better idea and be able to flesh it all out.
Onto infrastructure. Infrastructure is one of those things you can't live with it, can't live without it. Like, it's a spectrum. You can imagine on the far end of one side that you have a guy in Notepad with a compiler, and that's his whole infrastructure. You can imagine on the other far end of the spectrum where you have so many tools you never get to write your game because you've got all these different tools you've got to maintain and keep up and check and learn and do all these things. And so we're always trying to find that happy space in the middle. You wouldn't add a tool to your workflow if it wasn't adding some value. So you are looking for tools that will help you, but building out that infrastructure takes time. Maintaining that infrastructure also takes time. And if you don't, well, you don't have helpful tools, so it's going to take you forever anyway. So all of these things take time. You try to balance that and figure out the best path. But one of the reasons why game development in particular takes so long is because you have to deal with your infrastructure one way or the other.
That's particularly true of a new studio as well. If it's your second or third or fourth game, even if you're in a different genre or a different style, you can reuse some of your infrastructure, particularly UI elements and things like that.
One of the first things we ran into was realizing that game engines aren't magic. We had done some courses on Unity, right? They tell you everything you need to know about Unity. And very quickly run into, oh, it doesn't work like that. It doesn't do the things that I thought it was going to do. We talked about sprites and the custom tools that we made so that you can preview those animations. And that came because the correct way we were taught to do it is you create an animator, the animator needs a controller, the controller has animations that go on it, you have to link them together in this whole state graph. I mean, it takes like 5, 10, 15 minutes just to set this thing up.
Keystones for days.
And then so when you, if you have a humanoid shape and you have 100 different characters and they all use the same animator, then it's not that big deal because you can put several days into making it perfect, getting all the animations that you want, and reusing that over and over. But for what we were doing, every character has a different set of sprites that are doing different things. We might have a refrigerator that's opening and closing, and that's very different from the main character running around in different directions. So every time we were basically finding that we were redoing all of this work. And we're like, there's got to be an easier way to do this. And so we ended up creating sprite cycles, and you just drag your sprites on there. You can change the timing. We have a whole bunch of different options you can put on there for whether they repeat or when they trigger or whatever, but it drastically reduced our iteration time because we were able to just drop some sprites in there and see what's going on. The other thing, I mean, we've referred to fighting against the engine a little bit. If you want to make a 2D platformer, Unity is fantastic. They do that all day long. We didn't realize that what we were doing was not at all that. We wanted a 2D ISO perspective, and everything from your tile maps to your colliders to your perspective, everything's different, and you kind of end up fighting the engine a lot. And I frequently had the experience of Unity doesn't do this well, I'm going to make a tool, we're going to do this, whether it's handling the camera or pixel perfect or whatever it is we're trying to do. And then sometimes, like 2 years later, Unity would come out with a tool that fixed that problem. And it's like, well, okay, but I'm going to keep what I did because at least I have the code for that, I know how it works, I can tweak it and adjust it. But that's frustrating. So that happens several times, and sometimes it's just better to use the tool you're familiar with and you have control over, regardless. One of the other things that just kept happening is you sit down to work, you're like, I'm going to get things done today, you don't get to work today. Sometimes that's life, like your kid is sick or you have a dentist appointment or whatever it is, but sometimes it's infrastructure problems, like your internet connection isn't working today. You got to fix that before you can go to work. I mean, sometimes you can get some work done without it, but most workflows require an internet connection to be really productive.
Sometimes your engine woke up on the wrong side of the bed.
Or, you decided, oh, I'm going to update the engine. It's a minor update. It shouldn't be a big deal. 6 hours later, why is everything pink still? And like, you don't get a choice about those. These are problems that just kind of crop up, and they're in between you and getting the work done. So you get to fix this right now. You don't get to do what you sat down to do, and so it takes a long time because you didn't actually get to do the work you set out to do. You got to maintain your infrastructure and work those problems out. One of the other areas we really found ourselves fighting against the engine was with physics. If I had it to do again, my crystal ball is a little smarter now, I would have written my own physics engine for the 2D portions of this game. We were kind of like in between two different physics modes that Unity supports, and there's not a clean way to like turn them on and off and toggle back and forth. And so we were constantly fighting and coming up with custom solutions, and then there's this weird edge case that has a bug, and by the time I figured out that we needed something else, it was always like, it's almost working. We're just gonna get a little closer. We're gonna put this behind us and we can move on. It's not worth making a whole new system for this, but by the time all of those almost adds up, I really should have just bit the bullet and done it to begin with. The last thing is very abstract and difficult to explain, so I apologize up front. But the thing itself is abstract, so like I can't get away from that. We're going to get some examples that hopefully will make it a little more clear. But I've found when I'm developing things that sometimes I would get these problems and they would kind of formulate slowly. I felt it like up in the back of my head, just kind of lurking. And over time, maybe it's when I'm doing the same task repetitively over and over and it's really tedious and boring. I'm like, there's got to be a better way to do this. Can I just write a script or do a thing or something to make this easier? I'm tired of this. Or maybe it's because it's tedious and repetitive, you're introducing bugs because you missed something, you weren't paying attention, you configured it wrong, whatever. It just compounds and complicates and creates all these problems. And so, these problems would just kind of lurk in the back of my mind, and it's just like I don't know what to do with them because a lot of times there's not an obvious solution. Or it's not even clear like what class of problem it belongs in. And so the problem with the problem is that I don't know where to put it. If I had a similar problem to that, right? You can put it in the same class and be like, oh, I've solved this one like this, I can do the same thing, but a little different, I can tweak it, I can use that same pattern to come up with a solution. But when you don't have any other problems that you solve like that, it just kind of lurks. Sometimes it's even hard to write down exactly what the problem is. So do you put it in your management software as a bug or a problem or an idea? Like, where does it even fit? And if you can't classify it, it becomes very difficult to know what to do with it, or how you even go about solving. We talked about pathing and how we ended up creating a whole pathing system for our character. And so part of that solution was creating what I call nav grids, and they're basically a layout in the scene of what areas you can walk and what areas you can't. It's a whole bunch of booleans, basically, yes or no, can you walk here? But you need a way to visualize those in the scene, which, that was immediately a problem. I made some little gizmos that draw out on the scene that show you where those areas are. But you could have several of these nav grids in a scene. The way we architected the game, you might have 20 scenes open. And so you've got, 40 different nav grids floating around. You gotta go figure out which one is the right one. You gotta turn it on. You gotta go into the inspector and find the button. And it becomes really onerous to figure out where the things are pathable or not. And so if, for instance, you want to take a crate and stick it in the game somewhere, it may be just purely decorative, but you need to make sure that the physics collider is not blocking the path that your character is going to be trying to walk later. And so, especially in this game where you can't control the character directly, the player can't fix your design problem for you. They can't just like move the crate a little bit, it's better. You're hard blocked, the game's stuck and you can't progress. Like you're stuck. And so that's a huge problem. You have to be really careful when you start placing objects, even if they're just decorative. If they have a physics collider on them, it's going to matter. And so when you go to stick a crate in that's just decorative, you got to do a whole bunch of steps to find all the nav grids. If you're on a seam in between two levels, now you need the nav grid from this one and that one because they're going to overlap. You got to make sure that all of these things are going to work out so that you can place this accurately. And you may spend 5 minutes doing not even the thing you set out to do. You want to just put a crate in, and you got to do all this other work to go make sure that it's going to work. And slowly kind of formulated in my head that I just want like a button. I just want to push a button, see where all the nav grids are. If I can just see all of them, then I know for sure, okay, this is good, I can put it here. And it gets in the way of the creative process because you're probably not just going to put one crate. You want to do a whole bunch of things. You want to have little things in this corner and that. And every time you got to do that, you got to interrupt yourself for 5 minutes and go do this other thing. Your creative process gets broken up. You have to context switch every time. It's mentally exhausting to keep bouncing back and forth these different modes. And so eventually I got to this, like, I want to have a button somewhere that does this thing, but where do you put the button? Like, it's not even obvious. You still have to, like, go find a nav grid in the scene somewhere and select it and look at the inspector and push the button. Like, you're still interrupting your process every time you do this. And so there's this whole class of problems of, like, we have these things we do a lot. We need a place to solve that problem. And it took a long time to figure out the obvious solution in hindsight.
So the solutions. Well, some of the solutions for these infrastructure problems. The first two I had really talked about. Use your tools like they were designed, or else make some new tools. Don't try to fight your engine too much using, I guess, the built-in capabilities of it. Either say, this is not going to work, I'm going to gut it and write my own, or stay in what the engine wants to do. So when you have some of these intractable problems, like we were saying, it's very helpful if you can group them and classify them by what kind of problem they are. And sometimes that's difficult to do just because they're sort of abstract by nature. But once you start getting some solutions to them, you can form these sockets, and the sockets are where you can put any new solutions of that kind.
The first one's always harder because you haven't figured out the solution to that type of problem.
Yep.
And it's not even clear that it should be its own class of thing. But once you can establish one, then you start finding other problems that fall into that class. You're like, oh, I know how to handle this.
Yeah, a really good example is we make a lot of use of electricity in our game and things that conduct electricity, so metal, wires, things like that. And we use it to power up interactable objects, to open doors, close doors if they're laser gates or something like that. And making a wire is not the simplest thing. You need to run, maybe it needs one bend in it, and you're running it from point A to point B. But that means you need one straight piece of wire of any length you want, which means it needs to be a 9-sliced spray, and then it needs to come down to a certain area. You need a bend, and that bend needs to go the right direction. Then you need another straight piece, and you think through all the parts. Each of these needs to have a script on it that can actually conduct the electricity. And it becomes a collider.
You have to resize every time you move it.
All these different parts, it becomes a real pain to implement something that conceptually is super simple. And so what we end up doing is creating a wire editor where you simply just draw it on the screen, and it handles all the back end for you. It actually implements the stuff in the engine automatically. Great, that sounds like something that's pretty straightforward. What we found is that the wire editor was useful for other things too. So in the driving levels, for example, roads work a lot like that. We had a lot of right angle turns, four-way intersections. So we could just draw roads using the wire editor with just some small modifications to it. So that's a really good example of having a socket on where to put things, and it saves you so much time the second time around. A GDD, so this is a game design document. I definitely recommend. Again, this is another thing that could be a whole talk on it in itself. We did a terrible job. We knew they were important. We tried to make one, and it was woefully insufficient. But
Did the best we knew at the time. We were like, this is great at the time, and it was half of the things we did.
At best, that's very generous.
Yeah, you're welcome.
But even still, even with it being, I'd say 10 or 20% of what we needed, we still used it as a reference. And this was really important because, well, A, it kind of prevented scope creep for us in a lot of cases, but B, sometimes you would design something and make a design decision, and for whatever reason, you're working on something else, you don't need to come back to that decision until 6 months later, 9 months, or even a year later. You think, oh, what the heck did I decide? I have no idea. What did we do? What did we even implement before? We're the ones that put it together. We don't even know how it works. And so if you have a GDD, especially, I would really recommend thinking of your GDD as a living document instead of something static. Go ahead and change it, update it as you, or better even keep revisions of it, but update it as you make changes, as you implement things, and that way you can use them for reference, and it kind of serves as a little bit of your own internal documentation. And the last thing I really consider as a solution here is make a vertical slice of your game. Figure out the components you need, kind of from a technical perspective, from an engine perspective, from your own personal challenges, whether that's some art because you're not comfortable with art, or whether it's programming because you're not comfortable with that, or the engine, or whatever it is. Include a bit of everything you're going to need in your final game, just a little piece of it, and make a little slice of your game, and actually get the whole thing together. Include your UI elements, because those are some things, menus, navigating around the game. It's easy to think, oh, it's just menus, it's just a start button and an options button, but those can have a lot of challenges in their own. And by making the vertical slice, it makes a lot of those kind of bubble up to the surface, and you'll figure them out.
And all of the systems have to interact with each other, and that's where you end up finding a lot of bugs sometimes. And so make sure that all of your systems not only are there, but they're talking to each other in a way that they're going to eventually, so that you can sort out those bugs from the front, and then you can actually focus on making the game because your systems are solid.
And one thing that may sound really frustrating, several times we said, do a whole bunch of this work that's not really making the game. And it's like, well, that just sounds like extra work. It sounds like you're just making it take longer, not shorter. But if you're really watching what happens as you have problems implementing in these smaller areas, it'll cause you to really develop the tools and the mindset you need to make your game faster overall. So a couple of examples here. This one is pretty self-explanatory. The text you can't read, which is exactly the point. So our game, Elon, heavily customizes Unity to support the 3/4 ISO perspective, and a lot of the objects are not really meant to work like that out of the box. And so we have a whole lot of game objects that have children and children of children, and a single object in game, like a crate, may be 12, 13, 15 game objects. And when you do that, there's a lot of room for misconfiguring every time you go to implement. Every time you're dropping an object, you need 13 of them. Make prefabs. I know most engines have a concept of a prefab where it's basically a pre-configured collection of objects with certain settings on those. Use those as much as you can to really help yourself out and let you implement faster and iterate faster. Second example is the Elon toolbar. So this is something we made. It's added in to our engine. It's just for our game, and it has a whole lot of buttons that do stuff specific to our game. I really recommend making one of these. How long did this take us?
Oh, it took like 2 years before we... Why don't we have a toolbar? Oh, I don't know. That seems like a good idea.
So you can see some of the examples on here. Whether it's adding characters or objects into a scene. You can see the wire editor is the fourth button over. Some of the things with the pixel art inside Unity, it doesn't natively understand pixel perfect rendering. And so if something's right between a pixel, you might see a little jitter, and it might constantly shake. So we had a tool for pixel perfect snapping. Things for story states and dialogue. All these things that we reference a lot. Anything you do a lot, put in your toolbar. Make a tool for it, stick it in your toolbar.
That pink one there is the nav grid button that I was kind of talking about before. You push it, all the nav grids come on, you can see what's pathable and what's not. Push it again, it all goes away, so it's not making a mess. But once we had a toolbar, it was like, oh, I just have a button for that. Now I have a place to put the button. And now all those things that are of similar type, just make another button, just make another button. Having the socket for that gives you the ability to solve those problems in a particular way much more easily. It's like 10 times easier to come up with the solution when you get there. Quickly, I'm going to try and go over some of the communication issues. small teams can't do a whole lot of work because you're small, and large teams spend a whole lot of time talking to each other. So again, kind of like infrastructure, there's this balance of there's just the two of us, and we still have a lot of communication that we have to do. As you go up, it scales with the factorial of the number of people you have, which, spoiler alert, that goes up really fast. And a lot of businesses manage this in different ways. They'll have hierarchies or structures, like you have a team leader, and they talk to each other, and then they talk to their minions, so not everybody's talking to everybody, making chaos, but sometimes you need everybody to talk to everybody because it's the people who are actually doing the work that need to understand. If you're going through this hierarchy, you end up with miscommunication. So it becomes challenging. You got to find some way to manage how the communication is flowing between teams of different sizes. Sometimes you're going to end up with creative visions that clash, and resolving that takes time. And sometimes it may even be that one of you is wrong, and you have to go back and redo things. That's happened in both directions for both of us.
You can both be wrong.
At best, one of you is right.
Yeah.
So, and that's going to, again, depend on your structure and your hierarchy. There's not an odd number of us, so we can't just vote. We have to have a consensus. And sometimes that consensus looks like, I don't agree, but we're going to try it your way. And when you do that, you have to actually try. You can't just give half of an effort and be like, oh, it didn't work. You got to do it my way. That's not going to work for you long term, I promise.
It's honestly nice to get proven wrong sometimes too, because it means you're happy with the solution that you came up with, and that's great too.
As long as your goal together is to make the game the best thing that it can be, you want it to be the best iteration of itself, then it's really easy to get on the same page and say, did this game make it better or not? Let's do that. And you got to be really careful, especially if you're governing by consensus, so to speak. If someone comes in who's going to stamp their feet every time something goes wrong and insists you do it their way, you just can't handle that in a team and actually make progress. You got to subordinate them, have a master dictator who's now in charge or something to handle that problem, because it's just not sustainable. We have a to-do list, and so we would create a task and put some, whether it was a bug or a new art asset or whatever, and very frequently we would put this into our software and say, assign it, here's the thing that you need to do. But very frequently, because I'm not the best at art, or he's not the best at programming or bug fixes, we still have to go back and talk about that and be like, okay, I saw you ran into this bug, but did you try to this? Did this happen? Was this a thing? I just changed the system over here. Was that involved? And so all these other questions come up, and you end up having these layers of communication on top of your standard processes that, again, take a bunch of time and make video games take longer to make. The last one, money doesn't grow on trees, and funding your game usually takes some time too. So, on the small end, if it's just like an App Store developer fee, that's maybe the minimum. But if you're buying assets or paying people for voices or art or music, all of these things add up. You got to get that money from somewhere. So, are you working a part-time job doing this on the side? That's going to make your game take longer. We spent a fair amount of time doing contract work from our previous lives that paid the bills. We also like eating, that would help sometimes too, but sometimes it's, things we needed for the game, and so that slows down your development process because you gotta have some money coming from somewhere to make this work.
I think in the interest of time, I'm just going to jump to our example and talk through some of the solutions on the example itself, and I think this is a good picture of a lot of what we're talking about. We use Hack and Plan. There's nothing particularly special. I'm not trying to evangelize for Hack and Plan here. It works fine, but it's a basic Kanban board, and I think there are a dozen other solutions out there that do well. And this is a good way to manage your team. And if you think, I'm on my own, you're still your team. And even if you're one person, you still need management. As silly as that sounds, it is amazing how easy it is to lose context from yourself as you are moving between strategy and execution, So between game design, between getting in and actually implementing things. Having something that can keep track of the statuses and keep track of all the to-dos, and if you have multiple people who's responsible for what in the workflow, is very, very helpful. You might forget where your brain was 6 months ago, or even 6 hours ago, as you're moving around between different contexts mentally. In our case, we actually created each chapter of the game we broke out into its own separate boards. We tried to focus on one chapter at a time, and we even created a template board in Hack and Plan, which was each new chapter, we know there are 50 things we have to do. And that way we didn't need to think through each time, oh, how do we get started from the ground up? I forget what we did 3 months ago, I forget what we did 6 months ago. It's just right there on the board, all the basic tasks are ready to go. Also recommend really trying to separate, when you can, your time thinking strategy and thinking design versus your time actually executing, because they're totally different headspaces. And if that sounds silly now, well, maybe you're a lot better at it than I am, or maybe it'll hit you when you get into your game. But we actually more recently fell into like Mondays were strategy days, at least for a few hours in the morning, really figure out what's high priority, what are we going to do for the week. And then that way we could kind of Tuesday, Wednesday, Thursday, just sit in our corner and get it done. No distractions. It's a lot easier to not have to think about, oh, does this really fit in the game, or is this going to create some kind of extra problem or anything? You can just go do what you need to do.
It also makes sure that you have some time to think about, do we need to change directions? Is this working? Do you need that high-level periodic check-in of, is this even making sense for where we want to go, or are we just blindly marching forward and we're going to end up somewhere we don't need to be?
Another advantage of trying to keep a large to-do list is that if you keep your own pipeline full of work you can do, some days your brain just wants to do one kind of work and not another. And the next day it might be that kind of work and not the first one. And it really lets you just do what you're more apt to do on that day. Not every day, but a lot of days you can just be more productive by focusing on what you're going to be best at that day. So those are some of our solutions. And we've got a few minutes now. Anybody have questions? Yes.
So I ran into the same problem because with Unreal Engine, like there have been times where I would have like so many different ideas of like trying to execute this, execute that. So there'd be days, like you mentioned, where like my brain was just fried, towards the end, because we did this in school, and towards the end of the semester, my brain was completely fried. I was just done with it. It's like, because I couldn't come up with like any more ideas. Like I was just like, got it. Also another question. I'm sure you're familiar with Crunch. I think
Crunch, you said?
Crunch.
Okay.
I'm sure why games take so long to make, because they want to avoid crunch, because I have heard horror stories about how developers like working late hours, staying at the office, and being there for months or.
Oh yeah, not even going home.
Yeah.
So we are our own boss, so if I don't want to work, I don't want to work, but then that means the game takes longer to make, right? So I have to balance that. I have tried to make sure that, this is a thing that we enjoy doing, we're not just torturing ourselves.
Yeah.
But crunch really is a problem with your crystal ball, right? And especially it's because management is dissociated from the people actually doing the work, and their crystal ball is saying, well, this should only take a week, why are you working so hard, right? And so the better you can manage that difference and improve the predictions of how long things ought to take and what you're doing, the better you can reduce the probability of that kind of stuff going on.
Yeah, I have one other comment about that too, especially for a first game. We did something that marketing doesn't like, but they're just going to have to deal with, which is that we really kept our game private for the first 5.5 years, I mean, maybe even almost 6 years, out of a 6-year development cycle. We knew after the first few months that we didn't know how many months it was going to be. We kept saying, oh, it's 6 months out, 6 months out, and we gave him a joke. 2 years into, 6 months out. We knew it wasn't going to be 6 months, but it still felt like it was. And
we would do the math. You'd sit down and work it out. I got this many things to do. It seems like 6 months still.
So I think a lot of that crunch happens when you're under a deadline and you know you have to be done. You've got a release date. That's it. You've gone public with it. And you might be able to push it back once, but you don't want to lose some of that marketing momentum either. You don't want to push it out too much. And so something we did with our first game, I don't think it's optimal for games in general, but we just waited a long time to get into the marketing side of things and make things public. And the nice thing is, once we start marketing the game's already done, or just about done. It's 99% done at this point, but it really let us control the timeline better. That said, if you are working with anyone in marketing, they'll tell you 6 months to market is really, really quick. They really want something more like a year. So if you're able to handle the multitasking, if you think you're far enough along that you really can commit to a deadline, it's much better to do that. But if it's your first game, there's nothing wrong with working in quiet for a little while until you have a better idea of what you're doing.
Anybody else?
Okay, yes. So I would like to ask one thing for sure, because there was like another panel that's do one hard thing first, but it's just like if you try like do the easy one the most of the time and then do the hard one last, would it be much easier if you just do the easy one first than just going back and do the hard first?
It's
Like
not
you just
easier to
put
do the
too much
easy one
pressure
first.
on yourself in other day that you're working on one project at a time.
Yeah, so one of the reasons why
Okay.
hard things are hard.
Sorry, the question is about doing one hard thing at a time, and what order do you do things in? Do you do the easier thing or the harder thing first?
One of the reasons why hard things are hard frequently is because you don't understand them yet. You need to develop your crystal ball so that you can better predict what's going on with that system and figure out your solutions. And so when you as you go through that process, since it's a thing you don't understand very well, you're probably going to end up having to change other parts of the game to make it work with what the final result of that hard thing is. For a while when VR was all the craze, VR was the hard thing that most people were doing in their games, and I think we had a note in here we didn't get to talk about it very much, but like try to do one hard thing at a time. And for those games, it was VR because that was new. No one really understood exactly what the constraints were. No one really was able to predict how well these things were going to work. So there wasn't a whole lot of innovation in terms of like gameplay or novel stories because VR was the new thing and that was the hard thing. And so they focused on that first. And now that it's developed a little more, you find some more creative expression in that area, in that game space. But did I wander around it? Does that help?
I think it does help. It's just automatically, it's just curious to see why everybody's just so struggle. Because most of the people struggle with this all the time, including while you're in college, while you're in high school. It doesn't matter where you at. It's just the point is like, hey, you just want to like get one thing first done before you just go down to another thing and just get done by right before a deadline. But it was just all about the pressure that you put yourself into. Like you were just killing yourself if you focus on one hard thing and then
Yeah,
focus on
yeah.
the easy
But when you
one.
get that out of the way, the other stuff kind of follows naturally, and so you know you're kind of over the hump, and it's a lot easier to fill in all those pieces that are a little easier. So, yeah, I'm very strongly in favor of doing the hard thing first.
I am not a dev. I live in the world of system administration, and something that we run into a lot is licensing for various tools that our company wants to use and asks
yeah.
us to do that. Have you, in the dev world of games, like you build your game and then eventually you'll have users playing your game. Have you had to deal with like any nightmares of licensing for any of the tools that you use to build your game that's now being consumed by hopefully as many users as possible?
No, we haven't. I think the big thing for licensing was our engine. And you all might laugh about this if you watch the news, but we licensed Unity and we did it on a per seat basis. And that's really it for us. Everything else, all our tools we made in-house, so there's no license to them at all. So, sorry, I don't have any more experience with it.
Oh no, I was just curious if they're like gotchas that you've encountered along the way with.
We
like,
haven't. I'm sure there are plenty of them out there that just hasn't been our experience.
And part of that was an infrastructure decision of we don't want that overhead and that weight of, there's a whole story about Unity changing their licensing that is a whole nother talk if you want to. We're in 109, come ask us, it's a whole story. But anyway.
All right, so kind of a double question here. So you do pixel art.
Yes.
So do you do artwork for like your main job when you're not working on video games, and
No.
you do programming? Is that something that you do for your main job when you're not working on your game?
Go ahead.
I got a degree in mechanical engineering.
Nice.
So I did that for a while. It bled into doing some programming in my original job, but by far my experience has been in this project, so that's been self-taught and learned, and we quit our jobs and started doing that. So
Nice.
And no, I had done no art before this
Oh, wow.
whatsoever. It was just a matter of noticing and tweaking and noticing and tweaking. And I think just, especially with art, it's just a matter of how much attention you can put in and figure out how can I improve this, how can I improve this over time.
What are your thoughts on automated testing when it comes to productivity in game dev?
I wish my crystal ball had been good enough that I could have done more of it up front.
Or automated testing was the question.
Yeah, and it's really difficult to, Unity has some systems for it, but it's just really difficult to configure tests in a way that accurately reflect the actual issues in your game. And then your game is changing over time, so now you gotta go back and make sure your tests are actually reflecting what's going on in the game. I know there are capabilities for that. I really didn't do it because it was just one more hard thing that I couldn't afford to do.
Yeah, one hard thing at a time. Or 4 in our case, don't make it 5.
I think last one probably.
What was your favorite level design?
That's a tough one.
I don't know, the later ones were always easier because we had more experience. They worked better.
Oh my gosh, yeah, it would be, the late, you're right, they were almost my favorite just because of the ease of implementation. Some of the early ones were, 6 months for a single room, and later on it was 1 design day, 3 implementation days, 1 testing and polish day, and we're good.
The tools were all working, everything was there. You
Yeah.
just get to actually do the thing that you signed up to do.
Yeah.
It only took 6 years to get to the place where you could, do the fun stuff. Cool, thank you guys for coming out. Like I said, we're down in 109. We have a demo if you'd like to play it, ask us questions, whatever else.
And feel free to join our Discord too, if you come up with any questions afterwards, we have cards up here.